Okay, so this is the problem that we're solving, and it's a tooling problem. So quickly try to sketch it out. So we have the shoulder is inclined at 45 degrees, and the forearm is also at 45 degrees. Okay, so we are given. So the first thing that we need, the lengths of each of these segments from EW and the SE, shoulder to elbow and elbow to wrist. We need the weights, we need the center of mass locations, we need the lengths. And here I'm going to ignore the hand for simplicity. Otherwise, if you do account for the hand, there's going to be a hand here and it's going to have a center of mass. But for simplicity, I'm going to ignore those terms. So in order to get the values for the center of masses and the lengths, we are going to use the table from the literature. So I'm going to quickly pull up our table of the lengths of the different segments in the body in relation with the total height. So this is the height represented by 1 unit here, and everything is in relation to that. We are interested in 2 parts, so this one and this one. I'm going to ignore the hand for this problem for simplicity, but if you want to do that, you can account that as well, and then it will be a 3-link problem. So I'm going to consider the lower arm and upper arm, or the forearm and the upper arm. So we need the lengths. The first length we need is this. It's going to be 0.146 times the height, and the height is 5'8". So 5'8" is equals to 173 centimeter, which is 1.73 meters. And so our link length is going to be 0.2525 meter. And looking at this data, we can find the center of the mass location. So forearm from elbow is located at, for the males, is 0.4172. We'll multiply this value 0.2525 by 0.41, and we get the value 0.1053 meter. So this is where the center of mass is located, and the weight of the forearm is gonna be 0.0178. So I'm gonna convert this to kgs. So this is roughly equal to 100 kg. So our mass is gonna be 1.78 kg based on this value. And then we also need to get the mass for upper arm. And upper arm is, let me get this, 0.0298. It's gonna be 2.98 kilogram. And then we need the lengths of the upper arm. It's gonna be this value, 0.186 times 1.73, which is equal to 0.321 meters, which is equal to 0.321 meters, or 322. And then we're gonna need the location of the center of mass on the upper link. And looking at this table, we see upper arm from the shoulder is, for the males, is 0.5269. So we are going to multiply the value we got with 0.5269, and we get a value of about 0.1 meters. So these are the values that we are going to be using for our calculations. Okay, now we are going to continue solving this problem. So this is, I'm going to assume the G acceleration due to gravity to be about 10 for simplicity. So this will be 17.8 Newton, and this is going to be 29.8 Newton. Okay, and this is going to be 200 Newton right here. We have everything that we need to solve the problem now. We are going to assume forces at this joint, Fex, Fey, the moment E, and we're going to solve it for this link. So for clarity, I'm going to isolate this link EW and I'm gonna put all the forces. Now we're gonna do a force balance on this link. So if we balance all the x forces, and like the previous problem, I'm gonna assume this is my plus x, this is my plus y, this is my positive moment. So we balance all the forces in the x direction. The only x force we have is Fex, so it's gonna be equal to 0. We're gonna sum the forces in the y direction now, all the forces. So the first force we have is Fey, and then we have a force vertical force 17.8, but it's opposite to our convention, so it's gonna be negative. And then we have 200 Newton, which is again opposite to our convention, so it's gonna be negative. And then those are the only two forces we have here. So we get Fey to be equal to 217.8 Newton. Similarly, we are gonna be solving for the moment ME by doing a moment balance. So we'll sum all the moments and it's equal to 0. The first moment we have is ME, which is positive, and then we are going to have a negative moment due to the 17.8, but since it's at angle, we are going to resolve it into two components, and our angle is 45 degrees here. Each of these components are going to be equal. They're going to be 17.8 cos 45 and 17.8 sin 45, but it's going to be same. So we're going to quickly add a moment due to that. 17.8 cos 45, and then that length, which is 0.1053. And now we're going to have a negative moment due to this 200 Newton weight as well. So this is gonna be 200 times cos 45, so minus 200 times cos 25 times the length. The link length is 0.2525, so 0.2525. These are the only ones we have, so it's gonna sum to 0, and we can compute ME as it comes out to be about 37.034 Newton meter. I hope my calculations are correct. And now we are done solving the forces that are coming over on the joints, elements for the elbow, and we'll now need to solve for the upper shoulder to the elbow. Okay, now we're gonna be solving for the second link, the shoulder to the elbow, and this is the setup we have. We have also forces here, Fex and then Fey. These are going to be exactly equal and opposite to the forces that we used when we solved for the elbow towards the wrist. So I'm going to put all those things here, and we know all the values. Fex is 0, Fey is, and then MA is 37 Newton meter. Okay, so now I am going to assume forces Fsx, Fsy, then a moment S. We're going to do a force balance, and the x direction is going to be 0 to the first force is Fsx. The second force that we see is Fex. It's going to be 0. Fes itself is 0, so Fsx 0. The second force balance that we are going to be doing is in the y direction, and the forces that we have are Fsy, which is positive, and then we have a negative 29.8 because it's opposite to the convention, and then we have a negative Fey. This is going to equal to 0. Fsy comes out to be about 247.6 newtons. Okay, now we're going to do the balance along the y-axis. Now we're going to do the balance for the moments. So summation of all moments is going to be 0. The first one we have is ms. The second moment is going to be due to this. Second moment is going to be due to this weight. Again, this is 45. So this is going to be 29.8 cos 45 and the distance is 0.17. Similarly, we are going to have a moment due to the FEY, and it's going to have two components as well. This is 45, and this value is going to be 217.8 cos 45, and this distance is 0.322. And finally, we are going to also adding this term, ME, and it's going to be opposite, so it's going to be minus 37 as well, and this is going to sum to 0. Solving this equation, we can find our MS, which comes out to be about 90.17 Newton meter.